Hello, welcome to another Dave Makes Stuff with nTop tutorial. Today I want to show you a notebook that I developed for making procedural stairs. You can see that these stairs would not be up to code, so please don't use them for making real stairs, but they're tons of fun to play with, and perhaps that you will find some tips or tricks here in this tutorial that you can use in your other design work or projects. Let me just show you a quick video of what this model looked like when I 3D printed it. So lots of fun to play with. Let me show you some other versions of the same print just to give you an idea of what's possible with this design process. So on this model here, you can see there's this tube that lies underneath the stairs, and that's just a sacrificial support structure for when printing with a resin printer. It just provides nice and even support to the bottom part of the stairs. This is a staircase based on the cinquefoil knot, and you can also input a different type of knot. This is a torus knot, and you can create similar kind of wild and wacky stair patterns. For the purpose of our demonstration today, we're just going to use this trifoil knot just to make it a little bit easier to render and see what's going on. So the first really important part to tell you about this notebook here is the first input is a spline, and it needs to be a closed spline. This notebook will not work on splines that have open ends. But I've developed a number of custom blocks here to make different knot type structure. Here again is the cinquefoil knot, and then the torus knot, another type of knot there. And these notebooks these custom blocks just have different inputs that determine the size and the shape. And I'm happy to make these custom blocks in this entire notebook available to you. I'll put links down in the bottom here. So first thing is our spline, guide spline for the knot. And before we go on to the first step is determining the wrong spot there. First step is determining step dimensions. Before we get into that, I just want to put up just sort of a rough structure of the stairs, just to kind of help visualize what's going on here. So there's sort of the rough stair structure. Going back to the first step here of determining the step dimensions, the minimum step spacing here, what that does is it places where am I here? It places a equidistant points along the curve, and that dimension of 4 millimeters in this case is the distance between those 2 points. And just to show you where those points are referenced on the actual stairs, it is the middle of the riser, so the middle side to side and up and down, and that's the point, that's the curve that we reference all of our stairs from. So I'll leave that up there. There's the points that the stairs around there. Of course, the minimal distance there, if I want to make my stairs stretch out a little bit, I can make that a little bit bigger. If I want to make really tight, small stairs, then I can tighten it up like that. The width is just of course, the width of the stairs. So narrow stairs. I find that roughly having the minimum step spacing at roughly half of the width tends to be good, and these are the settings that I use there. So starting from those points, the reference points in the middle of the riser, we use a bunch of processes here to create mid-riser lines. So those are lines that go across the middle of the riser, and then from there we can determine the edges of the stairs. Now, since this is such a important part of this design, I'm actually just going to go through the construction of a single step. So here we have, this is just an arbitrary point from the series of points that we're going to reference off of. And what we're looking at here is the, you know what, I'm going to just add all of our points on here. So there's all of our points. And so the piece that we're looking at here, I'm going to just turn this around. The piece that we're looking at here is just a single step amongst all of the others there. So we've got our central reference point, and then these are the lines leading to the adjacent points. There is our mid-riser step. So that's in the middle of the riser. And as you can see from, if I put them all up, these are all lines that are just in the XY plane, but normal to the curve. So we've got that there. And now as we create the edges on the riser here, what is happening here is this next edge, so this would be the top, this would be the nose of the stair above here, is being raised up half of the distance of the Z distance from this line right here, and the line below it is simply it's going down half of the Z distance from this point to the point on the adjacent stair. And once we have those reference points, we can use the create mesh face from four points to create, this is just a mesh here. So I've used that point and that point, that point and that point. And then you can see the tread on there as well. And that is just using the reference, that point and the point, the similar points on the previous stair there. So these meshes for the risers and the treads are used as reference geometry to create the different surfaces and the support structures underneath. So let's just jump ahead and render the full staircase here. You can see that the stair surfaces, the grading there is placed on that mesh, and but the other important piece that we're going to get into here is that if you look at the support structures, these sort of plates that extend below the stairs, they extend down into an angle like this. And so we're going to also be using mesh reference geometry to drive the extrusion of those support structures underneath there. So let's close that off. Let's take a look at our reference meshes here. So first off, I want to show you a mesh that is not actually used in the creation of these stairs, but will help us go through the how these mesh structures are created. So this is just a flat, almost ribbon-like surface here, and each of the lines that makes up that mesh is in the XY plane, and again just follows that curve around. So once you've created these lines, and each line has a start point and an end point, what you can do is use those start and end points and the mesh face from points block to create two series of triangular meshes. Now you can't use 4 points as we did in the stairs because these 4 points are non-planar, so you have to create the surface using triangles. So there's one set of triangular meshes, and then the second set of triangular meshes just fills that in, and then you can merge it all together. So we don't actually use this reference mesh in the creation of this particular procedural stairs, but what we do use is a similar reference mesh that creates sort of a triangular base at the bottom, an angled point at the bottom. And that is done by using these lines, but then also a series of lines underneath that creates that lower point. And again, if we just look closer at the construction of this, we're creating one set of triangles, then we're creating another set of triangles, meshes, and two more sets of triangles there, and we're merging that all together. And one more measurement or parameter just to share about this angled mesh here is the line here, bottom line offset. So that is referring to the bottom line, the apex sort of that triangle, and how much lower it is compared to the upper sections there. So let's change that to -10, and you can just see that it creates a sharper angle there. So we will get back to this and I'll explain a little bit more about what it is used for. Let's put it back to its original setting there, and we will hide that and go on to the tread supports. So let's just make these visible here. So the tread supports are just graphs that are referenced onto those initial tread, the quadrangular quad meshes that we built earlier on, and that is what that forms is the support structures underneath. So these angled plates underneath there. And so just looking at that, because it's a unit cell, we can modify that. We can use different graphs of the graphs. Now, of course, that's not, if we look at how that renders into actual supports, that of course is not going to do a great job. So let's just put that back to our ISO truss. That seemed to be the one that worked best for this. So there's the graphs on the on the top of the tread supports. The really tricky part though in designing this was to figure out how to get them angled at the bottom, because as you can imagine, that's important not only for the strength, the structural strength of it, but also because it is needed for if you're manufacturing it by resin printed or some sort of additive manufacturing. You need a point section that you can attach to, and the stairs can generate on top of that. So that was the tricky part with this, and for that we used the angled mesh. So there's our original angled mesh. This right here, the lower reference mesh, gives us that mesh there. So it's just been lowered a little bit below, and that just positions it better to the graphs right there, because that's the angled mesh there is going to dictate how far we can extrude the graphs in a lattice and how far they'll go down. So we're kind of building things there right now. The other parameter here is tread support lower, and all that is doing is lowering the support graphs slightly down from where the stair treads are going to go. So if we kind of jump ahead and look at the finished piece here, and if you're looking closely there, you can see, so these the bottom ones in this sort of angle, that's what we're building right now, the tread supports, and the but the they lay further below these upper treads right here. So that's what that measurement is right there, 0.3 millimeters. Just lowers it down a little bit. And then there's this fancy block here. We're down here. So distance along direction, and that gives us a scalar field. The distance from the points to the mesh according to this direction that we've inputted right here. And so that field is what we then use to create a point map, and then that is what we input into the extruded supports block here to determine the height. So it's basically growing the graph, the lattice downwards to the point where it makes contact with the angled mesh under there. And that is how we get that nice angled bottom there. This last piece here is just it's called bottom support tube. So you can see it's just a tube that attaches onto the bottom, and again, that's good for structure. It's also good if you're for attaching supports for when you're printing this. It just gives it something a little bit more robust to attach to, and that can be adjusted up there if you want to change the diameter of that. So that is our tread supports, what's holding everything together. Let's close that up. Actually, I'm going to just make it go away here first. And we will go on to the tread surfaces. So again, these are just referencing off of the tread quad meshes that we formed earlier on. And I'm actually using these new, as of this tutorial, these were a beta block, the graph on quad mesh and the 2D unit cell. And I'm putting that into the extrude lattice. And so if I take that off, there's just the rectangular one. If we want, we can do a face-centered like that, or the diamond one is another option. These other ones don't work very well because the quad cells aren't all uniformly oriented. So I just am going to go with that one. And we use that lattice to plug into the extrude lattice. And here we have a few parameters that just affect the tread surface height. So that is if you want your treads a little bit thicker. And then of course the thickness of the graph on there. So we'll leave that as is. And let's move on here. So what is coming up next here is our balusters. So those are just to show you right off the bat, there is our the upright sort of struts that hold the handrails. And this measurement right here is just how high they go, like that. And this measurement here, the bottom overshoot, is just how low they go. So if we put that at 0, you can see that they're all referenced off of this this mid-riser line here. So if we put the overshoot at 0, then all of the balusters just start at that mid-riser line there. But I think it looks a little bit nicer if they come down and just you can see them all the way down to the bottom of the tread supports there. And then of course here we can adjust the thickness easy enough if we want to do that. So those are our balusters. Get back to that one there. And I'm going to turn on our tread supports just so we have a bit better image of what things are looking like as we generate them. We'll close that up. And then the last thing is the railings, and they're formed quite simply. They are just basically splines, thickened splines that follow along the top surface of the balusters there. And again, railing thickness there. And this input right here, the mid railing lower, is if we want to have a second railing on there, like that, sort of in the middle. All this is doing is translating the upper railing down like so. So that's an easy way to add a mid railing on. And there you have it. There's the trifoil stair, procedural stairs. I'm just going to close that up, and where's all our other things here? So close everything else off, and let's just turn on the full stairs. And there you have it. There's our trifoil stairs. And of course, it is so nice being all procedural. We can just, if we want to, we can remove that trifoil knot there and put in our cinquefoil knot, and that will run through and generate. And just like that, we've got our cinquefoil stairs with the same parameters, and it's that easy. So I hope you enjoyed it. I hope that you found something in this tutorial that's useful in your own design work. And I'm going to now play the video of the entire design and fabrication process for the version of this that I 3D printed. So please enjoy and tune in for the next tutorial.